Good morning, Suvidu. Good morning. What are others online now? Good morning, Anthony. Alara, good morning to you. Watila, good morning. Hope everybody is doing well. Yeah, good morning to you who has just connected. In 1 or 2 minutes, we can start our lesson. Uh-huh. Bikini, scenery, view. Yeah, welcome everybody. Good morning. Yes. So, can we start our lesson? අයිබෝන් ළමයි ආයෙත් ඔයගොල්ලෝ හැමෝම සුවෙන් ඇති කියලා හිතනවා. අපි අපේ පාඩම් කටයුතු කරගෙන යමු පුරුදු විදියට. Last day, in last 2 days, we have discussed systems of pulleys. Mainly, the principle we introduced was Newton's second law of motion in the form of the formula F equals ma. It is F equals ma. The main tool that we have to explain many more things. Today we are going to another section, another case where we explain the motion mainly using F equals ma, right? F equals ma. Our topic is motion of a wedge. Motion of a wedge. So last day, in last 2 days, we discussed the motion of connected with systems of pulleys. So this one is a bit different, but most of the questions in this section are connected with wedges also, with pulleys also. So in this, you will see more and more questions connected with pulleys. That's why I didn't give more homework or exercise under pulleys only, right? So what we have done for pulleys only is sufficient. In this section again, we will do take more examples, exercise connected, wedges connected with pulleys also, right? So motion of a wedge is our topic. Wedge කියන්නේ මොනවාද? සිංහලෙන් කියන්නේ කූඤ්ඤ කියලා. ලියන්න ගියාම අමාරුයි ගණන් හදනවා වඩා. කූඤ්ඤ ගැන අහලා තියෙනවනේ තමයි. පොඩි කාලේ මොන්ටිසෝරි ටීචර් කියලා දීලා තියෙන්නේ මොනවද? කූඤ්ඤ ගලවගත්ත වඳුරගේ කතාව. අර ඒ කූඤ්ඤ තමයි නේ. මොන්ටිසෝරි ටීචර් එක කියලා දුන්නේ නැත්නම් මේ දවස්වල ගෙදර ඉන්න නිසා අම්මගෙන් හරි තාත්තගෙන් හරි ආගන්න. ඒ වගේම තව කතාවක් තියෙනවානේ මොකක්ද මේ මහින්දට විරුද්ධව විශ්වාස භංග යෝජනා ගෙනපු ආණ්ඩු කුමාරගේ කතාව. ඔය දෙකම එකයි. Tamanට අදාළ නැති වැඩ කරන්න ගියාම සිද්ධ වෙන්නේ මොකද්ද කියලා තමයි ඔය කතාව දෙකෙන්ම කියන්නේ. ඒක අහගන්න ඕනේ තාත්තෙන් අර මොන්ටිසෝරියේදී අර කතාව අහලා නැත්තම්. Anyway, so in this, as I said earlier also, no new theory, just we learn how to apply F equals ma mainly, F equals ma to explain motion of a wedge, motion connected with the wedge, right? So I don't hope to give any note. Instead, we'll try to get some idea with an example, right? I'll give a question, an example, with what you can understand almost everything that you need to know about motion of a wedge, right? So we'll take down this question, example. A smooth wedge. A smooth wedge of mass capital M is placed on is at rest on a smooth horizontal plane. A small smooth particle of mass simple m is placed on the face of the wedge, which is inclined to the horizontal by alpha, right? Now the system is released. Now the particle released from rest in the subsequent motion. Find these are the questions. Number one, acceleration of the wedge relative to the plane. Number two, acceleration of the particle relative to the wedge, right? Three, reaction between the wedge, the particle, between the wedge and the plane. And the plane. Part 4, reaction between the particle and the wedge. Particle and the wedge. And finally, the distance traveled by the particle on the inclined phase as the wedge moves, as the displacement of the wedge is d. The wedge moves on the plane. If it moves the distance d, what is the distance traveled by the particle? So this is a full question. You can take it down, right? This example, you can take it down, then you can start analyzing it, discussing it. ඔකල නිකන් ලියා ගන්න ළමයි. ඊට පස්සේ මාත් එක්ක විස්තර කරන්න. Right? First you just take it down. After that you can discuss it. Yeah, good morning to everyone who has just connected. Finished, everybody? So is it inclined to the horizontal by alpha? Alpha, horizontal by alpha. Okay, now we can start the answer, the solution. Basically, this is the diagram, but as we discussed earlier also, we are going to apply F equals ma, right? To apply F equals ma, in the diagram we have to mark F, forces, and A, accelerations, right? Forces are obviously there are two waves, capital NV and simple NV, two waves. Moreover, there are reactions. So there is a reaction between the particle and the wedge. And there's another reaction between the wedge and the vertical plane, right? All these are smooth, as we assume. This is a R is the reaction between the wedge and the vertical horizontal plane. Then let's take some S, a reaction between the wedge and the particle. See, some S perpendicular to the plane, equal and opposite reaction on the particle, equal and opposite to the reaction on the wedge. So these are the forces acting on the system. So moreover, we have marked accelerations. Okay, there will be an acceleration as this particle is released. It will start to move down the plane, right? It's a smooth plane, smooth particle. You release the system from some point, like somewhere here, say, then the particle will start to slide down the plane. So it will have some acceleration. The particle will have some acceleration relative to the wedge. So let's give some name. Say A, simple A. Acceleration of the acceleration of the particle relative to the wedge. Then, because the system is on a smooth plane, as the particle climbs down, it will create a momentum horizontally in this direction. A momentum in this direction. The particle will create a momentum in this direction. Then to neutralize that, the wedge will start to move horizontally backwards, right? To neutralize that momentum. So the whole system, the wedge, together with the particle, will start to move in the opposite direction, horizontally in the opposite direction, say at some acceleration v relative to the Earth's frame. So better we explain the accelerations as we have done in police also, systems of police also. Here better you explain them. Acceleration. Accelerations. This is the acceleration of the wedge relative to Earth's frame. Acceleration of the wedge relative to the Earth frame is v in this direction. This is the acceleration of the particle relative to the wedge is climbing down, right, down the plane. Acceleration of simple m relative to capital M is down the face of the wedge at an angle alpha. At an angle alpha. If you want, you can further explain acceleration of the particle relative to the Earth frame horizontally and vertically. So horizontally, if you take horizontally, acceleration of the particle relative to the Earth frame, horizontally, it will be b minus a cos alpha. b minus a cos alpha, this angle is alpha. That's the acceleration of the particle relative to the Earth frame horizontally, right? Then vertically, acceleration of the particle relative to the Earth frame, vertically it will be a sin alpha. Come down, this angle is alpha, this is 90 minus alpha, so it will be a sin alpha downward. So this is the explanation of accelerations of the system, right? Okay, now, okay, you first take it down. You can copy the diagram. Why do you mark S for both directions? The downward S is no. Again, no. Again, remember that we are not in statics. We are not considering systems in equilibrium, right? These are the systems in motion. As the systems start to move, the parts of the system start to move, things become really different to what you see in statics. S is not just force by mg. It is the reaction between these two, the particle and the inclined phase, right? There is some reaction on the particle, then Newton's third law. There should be an equal and opposite one on the wedge. Here also there should be an equal and opposite reaction on the surface, maybe a table or the floor, but we don't mark it because we are not going to do anything with that. We don't need that. We don't mark the other thing, the other reaction here, but this one, this test and this test, both are in the system. We need to take them, right? Not just goes by mg. There are accelerations x equals ma. The force is equal to mass into acceleration. Accelerations also has some effect, not just the masses, but not just the weights. Accelerations also has some effect when the system starts to move. Okay. So you can copy the diagram, and after this, thereafter we will discuss. We will discuss like how to apply the formula and in what directions to get the quickest answer, right? How to get the quickest answer. We will discuss the quickest and the best part of working it out. Okay, now read the first two parts. And I give you 1 or 2 minutes. Don't write anything. Just plan what to do. Remember that. The main tool we have is F equals NA, right? So how to apply it, on what, in which direction. Is there a specific place that we should mark R? No. There is no specific place. For R, you can mark it anywhere here. So mg also, usually mg is acting at the center of mass, but you don't need to find the center of mass. And it is, you just mark wherever you want. The reaction R also, we don't need to find the place here in for our purpose. In mechanics, here we don't need that. If you come out with that, the client will be in a Right. Now, can you say for the first two parts? For the first two parts, we need the first part is to find the acceleration of the wedge relative to the earth frame. That's d. We need to find d. The second part, acceleration of the particle relative to the wedge. So it's a. So in first two parts, we need to find a and b. For that, we have derive equations. Derive equations. We apply frequency as we said before. So now, can you say applying f equals ma on what? Which part? Or yeah, on what? In which direction? To start with, apply f equals ma on what? In which direction? Just guess. Yes, gravity effects. The acceleration A, B are caused by the gravity, but not directly. Not you can't say that A is equal to B cos alpha or B sin alpha something, but that is the cause, right? Which creates these accelerations. Gravity, due to gravity, the smaller particle will start to slide down, and that will generate acceleration A and B, right? But not directly equal to, not A is directly a component of G. You have to compute it. Now my question, applying F equals ma on what? In which direction? Discuss. We need to find B. To get an equation containing B. Apply F equals ma on what? In which direction? Balang kana para karigan. Whole system horizontally says running loop on the particle civil horizontally on the wedge. Different answers. Running loop says horizontally again. Taking the wedge along, many things will involve. Okay, let me taking the wedge along R, MG, B, S is equal MG, everything will be there. So taking the wedge along is not the best thing to do here. To minimize the unknowns, yeah, as Ranindra says, to minimize the unknowns, we can take the whole system, then at least S will not be there, right? But R will be a bother. S will not be there if you consider the whole system. These two S will cancel each other, but R will be there. We can choose the direction, right? To get rid of R, we will apply horizontally. So what Ranindra says is correct. You take the whole system and apply horizontally, right? Not to the particle rushing, particle to the direction of its motion. Oh, okay. That's what we are going to do next. We start by the simpler equation. You can derive a simpler equation by taking the system and applying horizontally. This is like a Then we will see what to do. Okay. For the system horizontally. So we are going to apply for the system the horizontal direction, horizontally in this direction. Okay, can you say the left hand side force, the net force acting on the system horizontally? What is it? What do you write on left? The net force acting on the system horizontally, or the forces acting on the system horizontally, of the system. What is it? Yeah, Matila says 0, 0, 0. Yes, yes, your answers are correct. So there is no force on the system horizontally. So the left hand side is 0. That's why I said you're going to get a much simpler equation. So we will take it first and then think about the second equation. Okay. So it's 0. The left hand side is 0. Right? Then if you take now we are applying for the system, you take the wedge along, its mass is m. Remember, last I told you, F equals ma in our purpose, in this mechanics, we apply only relative to the earth frame, right? So for the wedge m and relative to the earth frame, the acceleration horizontally is v. So mv plus there is the particle also. We take m, simple m. The acceleration of the particle in that direction, in the direction we have chosen, is this. We have written it at the beginning. It is v minus a cos alpha. V minus a cos alpha. Two unknowns are a and b. Better we separate them. So I'll write 0 equals, taking v out, value m plus m minus na cos alpha. Equation number 1. Equation number 1, we have two unknowns and one equation. So definitely we need another. So how to get another? Sachin? Yeah, we can go to your option now. Now we need another equation. Now the best thing to do is consider the particle. So the particle we apply along the plane in the direction it is moving. In the direction it is moving relative to the wedge, right? Not relative to the frame. It's not easy to explain motion of the particle relative to the frame. It's moving in this direction relative to the wedge, right? So equation number 2 to get that we apply for the particle for simple m down the plane. The left hand side, force acting on the particle in that direction, S will not affect this S. Rather, this S will not affect. It is in the perpendicular direction. So only the component of mg will be there as a force. Now the plane will be mg. This angle is 90 minus alpha. Mg sin alpha. So the force, the left hand side is mg sin alpha equals the right hand side acceleration of the particle down the plane. No, we don't need this rather. Make a makala down. Makala name will change it. Down the plane it will be. You don't need that. Down the plane it will be a, and the wedge is moving in this direction, taking the particle also. So this particle will also experience this acceleration v. So the component of that component of B in our selected direction, alpha, it is B cos alpha, right? So the acceleration of the particle along the plane, the downward direction is A minus B cos alpha, right? It is A minus B cos alpha. This is what we need. This is what you need. Down the plane, it will be A minus B cos alpha. You don't need the vertical component most easily, right? Uh, so acceleration, the particle acceleration is A minus B cos alpha. In this, if you want, you can cancel M, but you will have to rewrite it later on. If you cancel it now, better keep it there, right? In B sin alpha equals, opening the brackets here, MA minus M cos alpha B. These are the two equations we have, right? These are the two equations we have, and these two are sufficient. We have two unknowns and two equations. These two are sufficient, and we need to find A and B. If you want to find B, we have to get rid of A. To get rid of A, the best thing to do, multiply this by cos alpha and add this. So A will disappear. So 1 plus 2 into cos alpha. That's the easiest thing to do. The left hand side will be nothing from this. This multiplied by cos alpha. Left hand side will be in B cos alpha equals, on the other side, A will cancel, can forget it, and the B terms are M plus M and 2, this multiplied by cos alpha, so that will make it simple M cos square alpha. I like it here. Now these two together, M minus M square, M cos squared alpha, that will give M sin squared alpha. So finally, B is equal to, you get the answer very easily. B is equal to MB cos alpha over M plus M sin squared alpha. This is the acceleration of the wedge relative to the frame. So this is the answer for the first part, right? And then the second part, you need to find simple A. If you have written this, I can during that part. Please check if you have corrected it here. I have changed the acceleration here. If you have changed it, now I can use that part and find out over the second part. No? Now we need to find A. We got an answer for B. We need to find A. What is the best thing to do? To find A, the best thing to do is here in this equation, the left hand side is 0. So you can take the advantage of that. Left hand side is 0. So directly you can express A in terms of B, right? By 1, your A is equal to B times M plus M over simple M cos alpha. I need M the subject from this, and then I can substitute for B. Usually, substitution is not recommended in solving these equations, but it's zero on right hand side when applying MA for simple M equation to. No. Run into now. Remember that always we apply in our purpose in mechanics, we apply Fickel's MA relative to the earth frame. So we found accelerations at the beginning, we wrote accelerations relative to the earth frame. Now we are using them, accelerations relative to the earth frame, right? Uh, to calculate the accelerations relative to the earth frame, we use the acceleration of simple relative to the wedge also. Sin alpha. Yeah, you are correct. One more agency. Misakya. This has to be MG sin alpha cos alpha. Yes, answer. It's the answer. It's correct. MG sin alpha cos alpha. Yes. Uh, now I am going to substitute for B, right? Uh, yes, sin alpha. Amazing. Hari, take a hello. Thank you. I substitute for B. B is this MG sin alpha cos alpha over m plus n sin squared alpha into m plus m over m cos alpha. The simple m cos alpha can be cancelled. Finally, the answer you get for A, the expression you get for A is m plus m g sin alpha divided by m plus m sin squared alpha. Okay. So this is how you find. This is like the quickest way of finding accelerations A and B. I think that these things are not that hard for you. The only thing you should see once how we use them. Political යාගන්න ළමයි. Political යාගන්න, and then we will discuss about the other two parts. The next two parts first, and there's part 5 also. හරි දැන් ක්ලියර් කරනවා. Finished, everybody? So, if so, we can go to the next part. Yes, yes. Anybody still writing? Dinuli usah butuh apa yang lain. Okay, shall we go to the next part? In part 3. In part 3, you will find the acceleration between wedge and the surface, the plane, the horizontal plane. It's R that we need to find, right? I gave to find R first. Oh, yes. It's better for part 3. For part 3, we write to find S, that is to find S, that is the reaction between the particle and the wedge. Shall we change it to 3? And for the part 4, we take to find R. For part 3, we write part 3 and 4 mark. So we first find S. You got any idea? To find S, what is the equation that we take? How to apply Ficus MA to find S? Ficus MA for the particle vertically, for M vertically. You are saying applying vertically to the particle. S sin alpha minus N equals. Okay, you can do it. That's also an option, right? There are many options. Okay, we can do that. You want to apply a particle perpendicular to the wedge. You can apply vertically also. If you take perpendicular to the wedge, you will have to consider B also. So you can forget B if you apply vertically. Okay, we'll apply it vertically, no problem. There are many ways. That's also an option. For simple M vertically. Part 3. This part 2, right? Part 3 for simple M vertically upwards. Vertically upwards, upwards or downwards, no problem. Upwards, it will be S sin alpha, S cos alpha. S cos alpha upwards. S cos alpha minus mg. Mg is coming down. Minus mg. There is no other force. There is no other force acting on the particle. If you take it vertically, S cos alpha minus mg. Then the right hand side equals m times b will not affect because b is horizontal and we are applying vertically, right? So b will not affect. Instead, but a will be there. A downwards will be a sin alpha, right? Minus a sin alpha. A is turning downwards. We are applying upwards, so it has to be minus m a sin alpha. So if cos alpha equals mg minus m cos alpha, for a we can substitute this. For a we can substitute that. We found a earlier, now I am substituting that. M plus mg sin alpha over m plus m sin squared alpha. Take the common denominator and simplify. M plus m sin squared alpha is the common denominator. This will go to the other side. Ng can be taken out, and simple Ng is common. Just 1 will remain here, multiplied by this. There will be m plus m sine squared alpha minus Mg gone out, capital M sine alpha cos alpha minus simple M this has to be sine alpha. This has to be sine alpha. So then m sine squared alpha, capital M sine squared alpha, or I'll write it like this, m plus m sine squared alpha. Right? M plus m sine squared alpha. Did you notice that m sine squared alpha is cancelled? No, not that. This one. M sine squared alpha gets cancelled, giving mg here, capital M minus m sine squared alpha. You take capital M out, it will be 1 minus sine squared alpha. So that will give capital M cos squared alpha over, I write G here, over m plus m sine squared alpha. So this is the answer. Cos squared alpha and m cos squared alpha G over m plus m sine squared alpha. Right? Yeah, that's what we get for S cos alpha. S cos alpha, right? It says cos alpha on left hand side. But the cos alpha will cancel, and for S you get only this. S is equal to cos alpha, G cos alpha over m plus m sine squared alpha. That's the answer for S, right? The reaction S. And that's the answer for part 3. We have S. In part 4, we need to find R. What is the best option? To find R, what is the best thing to do? To find R, what's the best thing to do? What do you do? To find R, the main tool is F equals MA. Apply F equals MA on what? In what direction? Vertically for the system. Lakshita says for the system. Okay, that's one option. Consider the system and vertically. That's what Suvita says. Any other idea? Now, some are saying you consider the system and apply vertically. You have any other idea? only the wedge. Say snake me. Only the wedge and then apply vertically. Can't we do that? Vertically to the wedge, yes. It's आपके agency. System and wedge on the end, apply vertically. Yeah, it's a better idea. It's a better idea because if you consider the system, the all A, B, everything will involve. Right? If you consider the wedge only, simple A will not involve, but B will be there. Still, you can get rid of B by applying vertically, right? Consider the wedge only. Consider the wedge only and apply vertically. It will be very easy, very simple, right? For the wedge, part O, wedge only. For the wedge, applying vertically, the forces are R minus S cos alpha. This is alpha. Yeah. R minus S cos alpha equals M. What is the acceleration of the wedge vertically? Acceleration of the wedge in the vertical direction. What is it? For the wedge, acceleration vertically. What is it? 0, 0, 0. Yes, it's 0. It's 0. So it's very easy. You see, that's the easiest thing to do. Consider the wedge and apply vertically. You get a very simple equation. You can easily quickly find R into 0. So R is equal to S cos alpha. S cos alpha, we found S a moment ago. This is S. Just multiply this by cos alpha. To make it cos square alpha, we will multiply by cos alpha. That's all you have to do. Mg cos square alpha divided by m plus n sine square alpha. And that is the answer, right? Right. So we found R and S. Mg not n plus n. Mg. No, that was n plus n. This one, Mg cos square alpha n plus n sine square alpha. This one is correct. Mg, maybe the acceleration m into acceleration of the particle vertically. You said it is 0. Not for particle, sorry, for the wedge, the vertical acceleration, there is no motion for the wedge in the vertical direction. Yeah, yamarne no. Wedge මේ පැත්තට යනවා. මම අර ඔයගොල්ලෝ නිතරම කියනවා මම කෙනෙක් ඉන්නේ යාව හැරවගෙන ඉන්නවා. Isn't MG coming? For that case, you mean that? Yes. I'm sorry. R minus MG. Yes, correct. This one, correct. Sorry, I thought you are asking about this side. Sorry, MG should be there. So you can take mg out and you can simplify to b. So mg can be taken out, and you are going to get m plus m sin squared alpha plus m cos squared alpha divided by m plus m sin squared alpha. ඔගොල්ලෝ හරි ළමයි මට එතන escape එකක් උනේ. These two will simplify and give just simple m. So on top you get r is equal to m plus m into mg over m plus m sin squared alpha. Okay, first I thought you were asking about the right hand side, but yeah, in fact there has to be mg here. Like this is the answer, a much simple answer. The simple answer you are getting. Yes, yes, you are correct. එහෙනම් මේ ටික ලියා ගන්න ළමයි. මේ ටික ලියා ගන්න. There's another part 5. I'll leave it for you. What about the weight of the particle? No. Weight of the particle will not involve here because you are taking only the wedge. You are taking only the wedge. Then the weight of the particle will not involve, but there is some effect of that. It will act here via S, right? So S is there for the effect of all this mg and simple a, whatever from the particle. But we are considering only the wedge, so you don't need to write down mg, but S will be there to represent the effect of mg and simple a acceleration or everything. Okay. So part 3 and part 4 you can take it down, and then I give you time to try part 5 rather, part 5. මේක ලියාගෙන ඊළඟ පාර්ට් එක කරන්න ළමයි තනියම කරන්න මම වෙලා දෙනවා. Okay, we will find you are given the distance traveled by the wedge along the flat surface, you need to find the distance. You have to find the distance uh, traveled by the particle down the plane, right? What the main tool that we use? That's all I need to know. What the main tool you used? Apply the main tool. We use in number 5. Apply yeah, S equals ut. Yes, S equals ut plus half at squared. Say for the wedge, we'll apply for the wedge. Part 5 for the wedge. For the wedge, we apply relative to the earth frame. It is clear known, relative to the earth frame. Relative to the earth frame in this direction, x equals ut plus half at squared. S is given. This travels a distance d, right? D equals u is 0. It started from 0 plus half relative to the earth frame. Relative to the earth frame, acceleration of the wedge is b. So it is half bt squared. So you get an equation b equals half bt squared, right? Then we need to find the distance traveled by the particle along the plane. So for which we will apply again S equals ut plus half at squared. This time for the particle and relative to the wedge. So you don't to apply those formula, uniform acceleration formula, v equals u plus at, s equals ut plus half at squared, v star equals u star plus 2s. To apply those things, you don't need to apply relative to the earth frame. You don't need an inertial frame to apply those things because the acceleration is fixed, right? So we can apply s equals ut plus half at squared for the particle along the plane. So simple m relative to the wedge, relative to the wedge downwards down the plane, we apply s equals ut plus half at squared. So value s is unknown. S is unknown. So let's write say some x there. U is again 0 plus half acceleration of the particle relative to the wedge is a, right? So half at squared. So you get another equation x equals half at squared. So we need to find x. D is given. I think the best thing to do is to divide these two. 1 and 2, you can get rid of t square. 1 and 2, so 2 divided by 1, you get x over d equals half t square will cancel off. X over d equals, you get like a over b. A over b, x is equal to a over b into d. So what about a over b? You can substitute for a and b, or you have an easy option. AOB, look at the first equation. Equation number 1, we have where we have started with. Equation number 1. Can't you find AOB directly from equation number 1? Equation number 1, it's 0 on left hand side. From equation number 1, you can find AOB. AOB. M plus M over M cos alpha into D. Isn't it the answer? From 1, right? From 1, AOB equals M plus M over M cos alpha. From equation number 1, AOB. Yes, this has to be the answer. Yes, okay. Then, okay, thank you. Then we can go to another question. So you learn almost all the basic things with this example. We didn't write any note. We took only an example. So I can give you a question from past papers. A bit more complicated case. Okay. Yeah, this here it is. Right, I'm giving you the question from the sum in 1986 paper, 1986. Viyatmet hadan nati. Aisara kadum. I'll do the diagram here. First part. Like the story is, it's a smooth wedge of mass capital N, of which this angle is 90 degrees, and two smooth equal particles of each of mass n and m, right? Each of mass n are placed on two faces, right? Placed on two faces. Uh, Placed on two faces and then released, right? You have to find the acceleration of the wedge relative to the frame. And the second part, they say, you connect. The second part is, they say the particles are connected by a light inextensible string which runs over smoothly at sea, right? Second part. Yeah. So here's a question. 1986 paper. You can take it down and start the answer. Hmm? So you have to start by marking things, necessary things in the diagram. First, let's mark the forces. The forces acting on the system. Weight of this particle Q, weight of P, weight of the weight, we don't need this, and our reactions, one from the ground, one between the weight and particle P, says 1, another between the other particle Q and it's 2, and the weight says 2. These are the forces that we have to mark. Then we'll mark accelerations. Accelerations. This particle P slides down the wedge, say relative to the wedge at some acceleration A. Then BO, this one also will note that this system is not symmetric. If this is A, if this is climbing down at acceleration A, you can't say this is also climbing down at the same acceleration A, because the system is not symmetric. This is alpha, this is some 90 minus alpha. Generally they are not the same, so it's not symmetric. So I'll mark some other B. Okay, then the wedge will move horizontally this way or this way. We don't know the exact direction for the movement, but it has to be horizontally. So I'll mark some acceleration C. Right now, now how many unknowns are there? So we want to find the acceleration of the wedge. So that is, you need to find C, but trying to write an equation for C, how many unknowns do you expect to involve? 5. Altogether there are 5, but when you try to find the acceleration of the particle in that equation, expected to involve not 5, not 6, only 3, as Russian says, yes. And Misaka agency also giving the same answer. 3, yeah, they are A, B, and C. When you try to find acceleration C, not R, S1, S2 will involve, right? Only A, B, and C. So we need 3 equations. I hope that you have written few, but I'd like to know apply efficacy on what, in which direction to get 3 equations. You start by applying. You started by applying efficacy on what, in which direction, and then followed by system. It has to be horizontally. So let's write it first. Then, but you need 2 more. How to get the other 2? System horizontally, and you first better you plan it fully. Then you need 2. We'll need 2 more. How to get the other 2? Applying on what? In which direction? In which directions? To get the other 2 equations? Yeah, on the particles in their respective directions. Yeah, direction of their motion along the wedge. Okay, so that way you can obtain 3 equations. We have known 3 equations. You have to plan it first, right? Plan it well. Then you can proceed. Hmm. For the system horizontally, here again, as we have seen before also, here again, the left hand side, F is 0. There is no horizontal force acting on the system. Yes, your answers are correct. For the system horizontally, there is no force. So the left hand side is 0. Equals considering the width along. But before that, it's better you explain the accelerations. I have forgotten it. They give marks for writing those accelerations, right? So you get 5 marks, sometimes 10 marks. Then don't forget to write this part. M relative to the frame, width relative to the frame is seeing this direction. This one, P relative to the frame. Downwards, it will be A minus C cos alpha, as we have seen before also. Then the vertical in the perpendicular to the plane. Now horizontally, then horizontally it will be C minus A cos alpha. Taking horizontally, it will be C minus A cos alpha. Okay. Then we go to the next particle and write down accelerations of that relative to the frame. Acceleration of Q relative to the frame. You wanted it around the plane. Now the plane will be this is 90 minus alpha. So it will be B plus C 90 minus alpha. So it's B plus C plus alpha. Then horizontally it will be C plus (90 minus alpha). It will be C plus B sin alpha. These are the accelerations of each part of the system, right? In useful directions, right? Now you said to apply frequency for the system horizontally. So we do it. So the force, net force in this direction is 0 equals mc plus, when you go to the particle q, simple m times its acceleration in the horizontal direction, we have written it. It is c plus b sin alpha. This for particle q plus particle p. So the particle p m into its acceleration in this direction, we have written it earlier. C minus a cos alpha. C minus a cos alpha. I'll separate the unknowns. Taking c terms, it will be m plus m plus m plus 2m. Take b terms, it will be m sin alpha C term, A terms, only this minus M cos alpha. Once you separate the unknowns, and that's what you get, right? And then you set to get the other two equations, you apply for P down this plane, for Q down its own plane, right? For P down the plane will be mg sin alpha, left hand side, equals m times acceleration we have written earlier, down the plane will be a minus c cos alpha. I'll separate the unknowns. You can cancel this term here. If you do so, you will have to reintroduce it later on. Therefore, no point of cancelling it at this moment. We will just keep it here. mg sin alpha equals ma minus mc cos alpha. Then we go to the third particle q and apply it in this direction. For q in this direction, it is mg sin alpha down the plane, mg rather cos alpha, mg cos alpha down the plane, equals m times acceleration of this particle down the plane. We have written earlier, it is b plus c cos alpha. And separate the variables. So mg cos alpha equals mg plus mc cos alpha. So these are the three equations that we get by applying reciprocal MA. First on the system, then on two particles. Will you please check your equations first before discussing how to solve the system? Equations වල අඩුපාඩු දෙනවා හදා ගන්නවායි. Acceleration of q. Acceleration of q. Acceleration of q down the plane there's a question about acceleration of q. I'll take it. This is the thing, this angle is 90 minus alpha, this angle is alpha, this will also be 90 minus alpha. So acceleration of q, this one down the plane, b is usually there, plus this is supporting, this is also in the, this is turning, we are taking down the plane, c is also turning in the same direction, c cos 90 minus alpha, so it is c sin alpha. Down the plane, it has to be b plus c. This has to be sin alpha. Can it be? Yeah, cos alpha sin alpha. Yeah, I have to correct it. So this has to be sin alpha. You are correct with it. This has to be sin alpha. Then the other one, horizontal force, please correct it here. It has to be b plus c sin alpha. Horizontally, c plus b. This is correct, I think. Horizontally turning This alpha, this 90 minus alpha. This is correct, I think. Yeah, this was the problem. Down the plane, b plus a sine alpha. So here I have to correct it. Down the plane, b plus a sine alpha. This has to be sine alpha. Agree now? Agree now? Only along the wedge was wrong. Yes. Yes, I have corrected. Yes. Okay, first check your equations. I have checked my equations. Now it's your turn. Then we can discuss about the method of solving. This has to be n sine alpha b. Sine alpha b. Right, now we can plan. Now we can plan our the way we solve it, the system of simultaneous equations. So we can say, right, we need to find b. Find b. No, sorry, we have to find c. To find c, we have to get rid of a and b. What is the best thing to do to get rid of a and b? Now look at these equations. Three equations. 1, 2, 3. Look at these three equations, and you can easily decide what to do. We want to find C, right? So how to get rid of A and B quickly? The quickest answer is so did you notice that in one we have m sine alpha b minus m cos alpha a, right? Yeah. Yeah, I think yeah, correct. I think it's the same thing I'm going to do. Let's say here. Yes, what is it? I think it's correct. So m sine alpha b minus m cos alpha a. So we can get rid of both a and b at the same time by making it m sine alpha b and m cos alpha a. We can create it. Multiply this equation by cos alpha is by sine alpha and subtract. So you will create this term here. This by sine alpha, this by cos alpha and subtract. Make it 3 into sine alpha minus 2 into cos alpha. Anybody finished it? Get the answer finally of B. Can you please tell me your answer? Answer of C, rather C. Finally, what is the answer? If anybody finished, acceleration of C. What is the answer? 0. Roshan says 0. What will I say is 0? Let's see. Let's see if it's correct or not. So we said we multiply this by sine alpha minus this into cos alpha. So the right hand side mg sin alpha cos alpha minus mg sin alpha cos alpha. Okay? Will be the same. When you subtract, left hand side will become 0. Right? Not on left hand side, it's just 0. The right hand side, this will give mb sin alpha minus ma cos alpha. Further, the c terms, I'll take mc out. Sine square, this multiplied by sine alpha will give sine squared alpha plus cos squared alpha. So that will equal to 1. Sine squared alpha plus cos squared alpha. So you take like 0 equals mb sin alpha minus ma cos alpha plus just mc. Number 4. Right? And we want to find c. To find c, we have to get rid of a and b. Now you can easily get rid of both a and b at the same time. Just subtract these two. 4 minus 1 or 1 minus 4. We'll take 1 minus 4. Both these will disappear. The left hand side will be 1 minus 4. The left hand side will remain at 0. It will be 0. 0 equals these two parts will cancel off. Again another 0 plus from the rest of the terms you get only the c terms remaining. This minus this will be just m plus 2m minus m plus m plus m. Yeah, actually you get m plus m into c equals 0, but m plus m is never 0. M plus m is never 0. That implies c equals 0. Your answer is correct. Your answer is correct. You're saying it's 0. This is question. Can a system make symmetric? No. Symmetric කියන එක symmetric වුණා නම් ඕක ඒට මේ යන්න පුළුවන් තමයි. Alpha symmetric වෙන නම් alpha should be equal to 45 degrees. Symmetric කියන එක නෙමෙයි. මම කියන්නේ ආපහු statics එක වැඩි පටල ගන්න එපා ළමයි. It's dynamics. Symmetric කියන එක නෙමෙයි ඒකේ අදහස. Whatever your alpha, this will hold the result. This result will be there. Alpha I have to know what is symmetric when and it is symmetric only when alpha is 45 degrees. Right? Apparently it's not symmetric. If alpha is 15 degrees, this side will be 75 degrees. So you can easily see that it's not necessarily symmetric. Anyway, you get a nice answer. Acceleration is 0. That means the wedge is at rest relative to the strain. ඒක නම් එහෙම වෙනවා. Finished, everybody? There's another part here, but I think that we don't have enough time to discuss that part. ඒක ඔයගොල්ලෝ තනියම කරන්න පුළුවන් නේද අපිට ඊළඟ දවසේ ඩිස්කස් කරන්න? Keep it for homework. The second part of this question, and I'll give few more. Okay. එහෙනම් මේක ඊළඟ part එකත් homework කරලා තියාගන්න. මේක ඊළඟ part එක I'll give few more from past papers, of course. 2003 question number 2 part B. තියාගන්න තමයි for homework. 2003 question number 2 part B. Then yeah, 2004 question number pada inna. Yeah, 2004 question number 2, a full question. I said question number 2 part B. 2003 question number 2 part. Then 2004 the full question. 2004 the full question, question number 2. හරි දැනට ඔය ටික කරන්නකෝ අදනේ පටන් ගත්තේ මේක ඉවර කරන්න ඔය දීපු අනිත් ගණන් දෙක හදන්න ඊළඟ දවසේ මම ටිකක් වෙනස් කරනවා ටිකක් දෙන්නම් I told you connected with police also, right? ඒවා ඊළඟ දවසේ බලමු තව ටික ලක්ෂණ ඒවා තියෙනවා පාස් පේපර්ස් වල තියෙන හොඳ ගණන් both the police and measures are connected in the questions එහෙනම් තමයි right අපි ඊළඟ දවසේ මේකේ තව examples කරමු අපි ඊළඟ දවසම ගන්නවා online ඊට පස්සේ තවත් දවසක් ගන්නවා හැබැයි මේ පාඩම අමාරු නෑ මේකේ තව examples කීපයක් කරාම බොහෝ විට ඇති වෙයි තව තුනක් විතර කරොත් ඕනනම් අපි තව දවසක් ගන්නෙමු අපි එහෙමනම් අදට පාඩම ඉවර කරනවා ඔයගොල්ලෝ හැමෝටම බුදු සරණයි නිරෝගී සුවය प्रार्थना करना